Assalamualaikum and salam sejahtera. In this lesson, we will learn about the application of the ideal gas law. Many chemical reactions, including some of the most important processes in chemical industry, involve gases. For your information, it is about 15 million tons of ammonia are manufactured each year by the reaction of hydrogen and nitrogen, according this equation. And it is necessary to be able to calculate amount of gases reacted. So, most of the gas calculations are just the application of the ideal gas law. Do you still remember from our previous topic? In the ideal gas law, if three of the variables, pressure, volume, temperature, and number of moles are known, and the fourth variable must be calculated. So, we try to solve this problem by using the ideal gas law formula. Okay, now we try to apply the ideal gas law formula to solve this problem. Okay, application 1. Okay, the high temperature decomposition of sodium azide to produce nitrogen gas is the reaction that used in the deployment of automobile airbags. Okay, this problem asks us to calculate the volume of nitrogen gas in liters at 1.15 atm and 30 degrees Celsius that produced by decomposition of 145 grams of sodium azide. Okay, now we know the values of pressure here and temperature. Okay, from here, we also can calculate the number of moles of sodium azide because we have the mass of the sodium azide, right? Okay, so we can use the ideal gas law to find the volume. Okay? Okay, first, we have to find the number of moles of nitrogen that produced, right, in these questions. But first, we need to find how many moles of sodium azide are in 145 grams. So, we can use this formula to find the number of mole of sodium azide. So, we have times the weight of the sodium azide times by the 1 mole of sodium azide divided by the molar mass of the sodium azide. Okay, this is how we calculate the molar mass of sodium azide. We have sodium, it is equal to 23.0 gram per mole. And nitrogen, we have 14 gram per mole because we have 3 nitrogen here. So we have to times by 3. And it is equal to 42 gram per mole. So we add both, okay, sodium and 3 nitrogen. We will get 65.0 gram per mole for the molar mass of the sodium azide. Then we will get the moles of sodium azide. Okay, we have 2.3 mole of sodium azide. Okay. Next, we have to find how many moles of nitrogen are produced in the decomposition reaction. Okay, here we have the balance equation. Okay, and according to this balance equation, 2 moles of sodium azide yields 3 moles of nitrogen. So, 2.23 moles of sodium azide, okay, will yield 3.35 mole of nitrogen from the calculation. Okay, so we have to times 2.3 mole of sodium azide by 3 mole of nitrogen divide by 2 mole of sodium azide from the balance equation. So we know the moles of nitrogen now, right? Okay, after we know the moles of nitrogen, we can substitute all the data that we have inside the ideal gas formula. It is equal to PV is equal to nRT. So now we want to know the volume. So we rearrange the formula. V is equal to nRT over P. So we know N for nitrogen, 3.35 moles. Okay. Okay, R we use the unit that we have liter atm per mole per Kelvin because we have the pressure in the liter. Okay. And we want the volume in the pressure in the ATM. We want the volume in the liter. Okay. And we also have the number of moles. And we have to convert the temperature to the Kelvin. Okay, the temperature that given to us is 30 degrees Celsius. So we have to convert it. Okay, so we have 30 temperature is equal to 30 plus 273. We have 303 Kelvin. So here. Okay. So now we can substitute all the data that we have inside this formula. So now we have the answer. The volume of the nitrogen gas is 72.4 liter. Okay, this is how we apply the ideal gas law to solve the problem. Okay, now we go to the application 2. Okay, this is the problem. Unknown gas bubbling up in the swamp is collected and placed in the sample bulb. And the density of the gas is 0.714 gram per liter at standard temperature pressure. Okay, calculate the molar mass of the gas. Okay, first, let us assume that we have 1 liter of sample, which is have mass of 0.714. Okay, because we have the density before. Density is given in the question. It is 0.714 gram per liter, right? So, we assume that we have 1 liter of sample, which has the mass of 0.714 gram. Okay? It is because the density is measured at standard temperature pressure. So, we know the temperature, pressure, and volume. Right? Because it is at STP. Okay? So, now we need to find the number of moles. Okay. So now we have to substitute all the data that we have inside the ideal gas formula. Okay. So we rearrange the formula because we want the number of moles. N is equal to PV over RT. So we substitute all the data. P is 1 ATM, STP. Okay. V is 1 liter. R we use the 0.06 to 0.08206 liter ATM per Kelvin per mole because the unit, okay, we have the unit here, pressure in ATM, okay, volume is in liter, and the temperature is in Kelvin. So we can use this R constant. So we have answer for the number of moles is equal to 0.045 mole. Okay, so now, so we know that molar mass of the gas, we know that the mass of the gas is 0.714 gram. Right. So we have divide by the number of moles. So we will get the molar mass of the gas. It is equal to 16.0 gram per mole. Okay, so that's all for our lesson in the applications of the ideal gas law. Thank you. Stay tuned.